talked about the works I've been doing for the last week also. So I've been focusing on creating 3D models based on GPT generated images as well as um, realistic images that I selected from my cell phone's gallery. So first off, let's start with GPT generated images. So those two robot um, image are generated by ChatGPT. It's part of a grand role-playing futuristic game that I kind of created using ChatGPT. So starting from the description, I created a GDD, and then based on that GDD, I asked ChatGPT to create all the necessary images of the roles as well as the descriptions for me. So we have the main character, some robots, a company pet robot, as well as the motorcycle that the character is using, and we have this security robot, which are supposed to be the enemy. Um, so after we generated this first script of the security robots, I was not very happy about it because this is a side 45-degree side view ish image, and in order to have a better generation with the modeling tools over here, we need a T-pose view. So I used ChatGPT with a few prompts over here, and it generated the first version of the T-pose view, which is not perfect. So we have a little bit of iterations over here, and we have a second version, which is a lot better. The reason that we need a T-pose is not just because we want the T-pose to be a better description of what the game character is going to be like, which is pretty much a standard approach for most gaming 3D model building. We also want the generated model to have a clear structure where the arms and the legs would be shown without connections in between. Because if you're not using a T-pose model, you would likely to have models like this, where you will have a connected adjacent parts. If you zoom in over here, you can see the hands are actually connected with the clothes, with the skirts structures over here. We don't want that. That's why we need a T-pose. We need a T-pose. So I generate a T-pose image over here, and there's another one which is not perfect, but it could be act as a supplemental side view-ish pose image, and this image over here would act as the main front view image of our generation. So a lot of and the next step, we use the image to 3D models for generation. So there are multiple choices for image to 3D generation on the market right here, and we want to use the most perfect one for our generation, possibly, and if necessary, we will break down the steps in between. For example, we can use some of the better modeling models over here for the 3D structure of the model. And this modeling model is not necessarily the best for generating the texture or the BPR of the model itself. We might want another model to generate the texture of the model for us. So here we have three leaderboard. The first one is 3D Ariana. So this leaderboard here could give us an overview of which model is better based on a human preference. So this model is entirely voted by real users. As a matter of fact, if you click into the model, into the leaderboard, you will see a page where you can rate different generations by different models yourself. And I use this Ariana for a more generic purposes, because there aren't there are many reliable ways to properly measure how good the generation of a model is. A human preference, a human voting weight could be a better way of examining whether the model is generating a good 3D model. But other than human preference, other than human evaluation, we want something that's evaluated by a mathematic measurement or a more objective measurement. So here we come with another evaluation which is called high 3D evolve. So we can see the paper over here. So this evaluation use a more mathematic way to examine the likelihood or the quality of the 2D to 3D generation. So from this leaderboard here in Hugging Face, we can see that Hunyuan, which is by Tencent, the Chinese company, is by far the best in literally every aspect, from the geometry generation to texture generation, as well as the prompt alignment. But it performed a little bit different from the human evaluation over here. It ranked number 7, but because it's developed by Tencent, so this model over here, it actually has a way better. It is hosted in a more reliable server, and it actually has a lot of other tools that we can use. So I'm choosing this Hunyuan, which appears performs really well in both high 3D evals as well as human evaluation. Rank number 7, number 6 actually. And so this is the first tool I'm gonna use. Another reason that we're using these tools is because, so let me do a little bit of translation over here. Where's the English one? Oh, okay. Apparently there is no translation for English. Anyways, so we can see that for most 3D model generations, there would be two important measurements or factors that we can see. The first one is faces. So the faces over here determines how many faces that we have. So 3D models are basically assembled by multiple triangle or square faces, as we know. And the more faces we have, the more faces that the model can actually generate basically means that we might have a more detailed model, because more faces there is, there would be more detail that could be presented by multiple different faces, like those little edges, these little scratches, as well as those little edges over here. The Tencent Hunyuan model can generate by far the most faces, as well as by far the most vertices. So that's the main reason that we are using Hunyuan as the model geometry generation. However, if we switch over here, you can see that even though in the mathematic evaluation leaderboard over here, it has the highest texture quality score by far, it's not generating a very well quality texture over here comparing to the original one. We have a triangle and a security over here. Although it perfectly match a lot of details of the texture over here, those little scratches because it's an old robot, the security is basically blurred out over here. We don't want that. So here we use another model, another tool, which is called Mesh AI, to generate the texture. Mesh AI's texture generation is actually not as good as what we have in Tencent. we can see that the texture looks way much newer, and it failed to mimic the color of the original original image prompt. But so this is basically why, in the first place, I prefer the human evaluation over the automatically numeric evaluation, because as a human we see things in a way that matches our purpose. So in my purpose over here is that I want the texture of this robot to to be generally mimicking the original prompt. But the most important part over here is this little triangle and a security symbol that we have, because it basically tell the user or tell the player that this is a security robot. So this security symbol over here is relatively important. Even though over here we can see in Hunyuan, this texture generation is definitely gonna have a way high scores if you are using a mathematic evaluation, because the texture, the color is aligning with the original prompt over here. But I don't see anything. The generation for this triangle logo and the security is basically a mess. I don't want that. This is not aligning with my purposes. So I want something different. It might be perform weaker in terms of mathematic performance, but it matches with my needs. So I use Measure AI for the generation, and it actually performed pretty well. It has everything I need, actually. And in order to put this 3D model into our game, a generic 3D model is not enough. We want the model to move. How are we gonna do that? We need skeleton. So here, in this case, we use Measure AI to generate the skeletons. You can use it over here. It's gonna rig the part. It's gonna rig different part of the robot's body away, using those little edges and dots over here. And it's gonna generate a skeleton where the skeleton can drive the robot to finish different kind of movements. So this is a finished prototype. If you see the skeleton also over here, you can see that the hands, it has about 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, about 12 movement parts of the body, and each part, it's going to control different part of the body and how it moves. There are a large set of animation over here that you can use. You can have the robot running, a different way of running around, walking forward. And over here, we have more animation. This one is my favorite. It's a 360 spin jump, which is really cool. So there, so since we have the generated model already, we wanna import the generated model into the game and test how the model is performing inside the game. Since I'm trying to create a 3D role-playing game, so here we have a 3D model template, a 3D game template, and I managed to import the generated model into this game. So after the model is being generated, you can actually download everything from with different formats. Mostly we're gonna use FBX because that's the most that's the most generic format for most gaming engines. So you can download the FBX through Measure AI over here, and actually basically all the tools provide multiple choices for packages. You can download FBX, GLB, in Tencent, Hunyuan as well as Roding. And let's take a look into how the model is performing in the actual game engine. So we have the robot with the idle animation moving a little bit around in the game template over here, and it can walk forward, jump. Well, the jumping animation was not imported yet, and because I want to test all those animation as well as how the skeleton is performing, so I imported the crazy 360 spin jump that I've mentioned previously before I even imported the jump animation. And let's see how they perform. If you press F, there we go. The robot is going to be able to jump in this crazy 360 spin forward. And let's take a look into how we managed to do that. So, of course, we first have the main blueprint, and with the model presented over here. So, of course, first we have to change the mesh. This is originally the 3D template little robot that it's provided by Unreal Engine. So you have to change the mesh over here with the imported FBX. And in order to make the robot move, we need to do a lot of changes in the blueprint as well. Well, I'm not a big fan of blueprint myself because it takes a lot of time to troubleshoot the blueprints. It does not have a debugging tools. You can't see what's going on in the memories. So if you're making mistakes, it takes you a lot of time. I will later transcribe this blueprint into a C++ way of implementation, but in order to make everything quick, I use blueprint over here. And this blueprint handles basically the walking movement with the it handles the overall movement of the robot with walking as well as the 360 spin. You have to do a little bit of transition if you wanna move. If you wanna have a new movement created with your robot. If you wanted to do some other movement other than just walking and jumping, you need to change the logic of the overall movement handling blueprint. You have to import more movement, and you have to handle what's going to happen before that animation, before that movement is being played, and what's going to happen afterwards. The logic here is meant to handle the 360 spin, incorporated with walking and jumping. In order to import all the animation and make it work in your character, you have to create these animation sequences as well. This is the one for walking, and this is for the 360 spin. You have to create the animation blueprint for different animation as well. As well as the blank space for your character. So let me try to find, yeah, there we go, the animation blueprint. So the animation blueprint is gonna handle how the animation is gonna perform, as well as some of the mapping with the keys that you're having on your keyboard. And this is more likely to be a subset of the overall blueprint logic that we have with how the character is being moved. So you can take a look into this. So this is a very simple moving forward animation. So I only used a very simple way of the blueprint to implement it. And because I simply just do not like blueprints, so I believe there would be a C++ way of implementing this, and I'm still looking into that. And thank you for sticking with me for almost 30 minutes, and that's it. As well as the blank space for your character. So let me try to find, yeah, there we go, the animation blueprint. So the animation blueprint is gonna handle how the animation is gonna perform, as well as some of the mapping with the keys that you're having on your keyboard. And this is more likely to be a subset of the overall blueprint logic that we have with how the character is being moved. So you can take a look into this. So this is a very simple moving forward animation. So I only used a very simple way of the blueprint to implement it. And because I simply just do not like blueprints, so I believe there would be a C++ way of implementing this, and I'm still looking into that. And thank you for sticking with me for almost 30 minutes, and that's it.